Good morning, everybody. Welcome to this Grow Your Knowledge webinar, which introduces circular economy principles for mechanical, electrical, and public health systems. My name is Anastasia Melona, and I'm Head of Research at CIPSE. This webinar will explore the new Research Insight on Circular Economy, which was just published by CIPSE, and is based on research that was conducted by Arup and UCL, and was sponsored by Schneider Electric and supported by AECOM. The publication aims to demonstrate the opportunities and barriers to implementation and potential value of circular economy thinking when applied to building services. We have two speakers today. The first one is Richard Boyd. He is a senior engineer at Arup. His background is in structural engineering, joining Arup's multidisciplinary design studio, Arup Associates, in 2011. After 4 years of design and construction experience in the UK, Middle East, and South Asia, his focus on embodied carbon led him to specialize in environmental impacts of construction products and supply chains. This work includes whole life carbon calculations for construction projects, the design and implementation of carbon management processes, and the use of circular economy principles with a set of tools and the inspiration for reducing emissions impact of our sector. He manages Arup's global partnership with the Ellen MacArthur Foundation and has led research projects on circular economy with the foundation, as well as with academic institutions like UCL and ETHZ. The second speaker is Harry Popwell. He's mechanical engineer at Rumble. Harry works as part of Rumble's buildings team in London. He was involved with this research project, applying circular economy principles to MEP systems as his previous role at Arup, and he has also co-authored the CIPSE Research Insight document. He has participated in industrial roundtables and cross-industry work, and is a firm believer that the key enabler for a circular economy in the built environment is deep collaboration. Couldn't agree more. The two presenters will be joined by a third panelist, which is going to be Joe Marino, to join the Q&A session. He's a mechanical engineer at Arup. Is part of Arup's buildings team, where he works as a mechanical engineer with close links to the energy and sustainability consulting teams. He has a strong interest in sustainable design and is involved in exploring circular economy principles and their application within the built environment. I'd like to thank the three speakers that they have agreed to talk at this webinar. The slides and the audio will become available to all attendees after the webinar. If you have any questions, please post them in the chat function of the platform, and we will answer as many as possible after the presentations are finished. That's all from me. Richard, over to you.
Thanks, Anastasia, for that introduction. And good morning, everyone. Very happy to be spending the next hour with you to run through the work that we've been undertaking with the past few years with UCL, as Anastasia said, also sponsored by Schneider and supported by AECOM. So if Harry, you can go to the next slide, please. So we've got 5 things that we'd like to run through with you today. We're going to aim to talk for about 35 to 40 minutes. So we want to aim to keep about 20 minutes for questions at the end. So please, as we go through, if there's anything that you'd like to clarify or anything that you'd like to explain further or just explore anything further, please make a note of your question and we'd be very happy to discuss it towards the end. I'm going to open by discussing a little bit of sort of the trends that we see impacting the built environment. That sort of provides the why for what circular economy, why do we need to be adopting a new approach in our sector? I'll then talk a little bit about what circular economy is, and then I'll hand over to Harry to sort of run through the work that we did with UCL and the conclusions and outcomes for that. If we go to the next slide, yeah, thanks. So when we think about trends, I'm not going to mention COVID, which is sort of the elephant in the room. I think that there's too much up in the air at the minute for us to maybe start to venture or speculate as to what the implications will be. So notwithstanding that, if we go to the next slide, the first big trend that I'd like to talk about is rapid urbanization. So between now and 2050, we expect the urban population of the planet to grow by 2.4 billion. If we go to the next slide, that's an increase of 64% on now. If we go to the next slide and press again, that growth is equivalent to 10.5 New York cities a year for 30 years in terms of floor area. So if we are to respond to this scope and scale of growth, we need to be ambitious in terms of our response, because we are talking about a trend that's operating globally and on a huge scale. If we go to the next slide. The growth of the built environment required to accommodate these new inhabitants is going to lead to significant growth in material demand. So by 2050, we're expecting demand for steel to double and demand for cement to go up by about 76%. And at the minute, those two materials on their own contribute a significant amount to global emissions, almost 10% by some estimates. So that's going to be a real challenge. Most of that growth is going to happen in the developing world, the lower middle and low income countries. In the high income world, here in the UK, we have a slightly different challenge. The trend is that of aging infrastructure. So if we go to the next slide, I think 87% of current UK buildings are still going to be in use in 2050. So the challenge here is slightly different. Rather than accommodating rapid growth, we're trying to adapt low performance or poorly performing buildings and infrastructure so that they're fit for the future. If we go to the next slide. And of course, but the background to why those two other trends are so challenging is that while we double the size of the built environment and while we try and bring our current infrastructure and buildings up to scratch, we also have to decarbonize them, and we have to do it now. We have to do it with urgency. So this graph is from the low carbon roadmap for the built environment that Arup produced for the government, the UK government, in 2012 and updated in 2015. And this showed across the full range of built environment emissions, be they embodied or operational, be they in buildings or in infrastructure, what actions needed to be taken in order to meet the then legally binding target of an 80% reduction of emissions from 1990 levels by 2050. Since the roadmap was first done in 2012, when it was updated, rather than the emissions going down, they'd gone up. And there's been a further 5 years since that update where emissions from our sector have continued to sort of stagnate, if not grow. So now we've lost a decade, and we've also just recently upped the ambition on that target, not from 80% reduction on 1990 levels, but to 100% reduction of 1990 levels to net zero. And so we need to start taking some pretty significant action. And this roadmap gives us the path forward that we need to take. If we go to the next slide. So if those trends, the growth, the aging infrastructure, the decarbonisation, from that I conclude we do need to adopt new approaches to the built environment in order to respond with the ambition and the urgency that we need to this challenge. If we go to the next slide. And for me, circular economy is the most compelling and useful model of all those out there for driving this ambition and this urgency and this response. What is a circular economy? A circular economy is an economy that has three characteristics. There are three principles behind what a circular economy is. The first is designing out waste and pollution, which is so far so obvious. And it's, waste can be what we throw out, but waste is also inefficiencies within our systems and sectors. So the amount of unused or underutilized space in the built environment, which seemingly is not currently classified as waste, but it is wasted. And again, the COVID crisis has highlighted the extent to which we have surplus floor space in the UK. Most of our offices are currently empty, while many of our companies continue to operate. The third principle is regenerating natural systems. So that is reversing the damage that we have already done to the natural biosystems that we rely on for our survival. And that's obviously a pretty key outcome for what we need to achieve over the next 30 years. The second principle, which I'll come back to, is keeping products and materials in use, and I'll add at their highest possible value for as long as possible. And the reason why I've come to that last is that we can achieve the other two, the regenerating natural systems and the design and waste pollution, if we succeed at the second one. So a lot of our focus is in how do we change our design approaches, our material specifications, but also the business models within which our sector operates, in order that we can keep products, materials, and built assets in use at the highest possible value for as long as possible. If we go to the next slide. I should say that these diagrams that I'm showing at the minute are courtesy of the Ellen MacArthur Foundation, which, as we mentioned before, Arup is currently the global knowledge partner for the built environment with. Their key diagram for defining what circular economy is this one. It's called the butterfly diagram. I'll say three things about this diagram. It's got a lot going on in it, so I'll just try and highlight the three key points. The first is the traditional linear economy is down the middle. You can see there it's about taking resources from nature, processing them into products, using them, and disposing of them. And the second thing that I'll mention that's key is that it's split between technical and biological cycles, blue technical cycles on the right, green biological cycles on the left. The key difference here is that the left is perishable and the right is durable. So anything that would cycle quickly in the economy, and we're thinking about biological perishable objects like food principally, would go on the left. On the right, when we're talking about things that are durable, capital goods, we're thinking about how do we keep them at their highest possible value for as long as possible. And the third thing is looking specifically on the right-hand side, on the blue side. The loops, the order in which the loops are drawn are important. So these 4 loops are 4 ways in which we can keep materials in use. And the loops are drawn that the shorter the loop, the more profitable it is to put a material around that loop. The less effort there is to do it, the less cost there is associated with it. So if we're thinking about circular economy strategies for our buildings, we need to think about maintenance and product life extension first. We need to think about reusing or redistributing things that we don't need anymore second. We need to think about refurbishing or remanufacturing things we can't find other uses for third. And it's only after we've exhausted all of those 3 other options that we get to recycling. And I labor that point only because for many people, circular economy is seen as recycling. It is recycling, but it's not just recycling, and it's recycling as almost a last resort. If we go to the next slide, please. The other definition for circular economy is that it's an economic system that helps us decouple economic activity from negative environmental impact. This is important because we know that in order to deliver the other, we use the UN Sustainable Development Goals as a framework for understanding what sustainable development and good looks like. For us to deliver the full range of sustainable development goals, we need to build human well-being, and human well-being for the time being anyway is going to be built on economic activity and growth. So the growth is good. We need to deliver good growth. We need to deliver low carbon growth, but we need to be able to do that without the commensurate negative impacts on the environment, and being able to decouple those as part of what circular economy is trying to achieve. Go to the next slide. The starting point for us as designers, of course, is that circular economy and the principles and ideas behind it offers us a design strategy. And a design strategy involved in circular economy might use the RAP design at waste principles from earlier this decade as well. It might also lead to reduced resource consumption, life extension, or reduced costs. Go to the next slide. But we also need to consider circular economy as a business strategy, because we need to be able to incentivize actors in the value chain to behave differently. If people have to act differently for assets to have values that change differently over time, or for us to make decisions that enable us to keep those assets in use for longer. And so by bringing circular economy in as a business strategy, we think rather than about cost, we think about value. We think about sort of keeping this highest value question about in use over time. And it's through delivering improved, more competitive, more profitable business models that we'll deliver systemic change. Go to the next slide. So these perspectives that I'm sharing with you today are born out of sort of a decade of work within Arup, exploring what circular economy means to the built environment. And we have very much we started with materials, we started with design. These are our sort of traditional strengths. But over that time, we've discovered and learned and understood that this business question, this business element, this business case is more and more critical. And so as the momentum and the number of things that we've been doing has accelerated, because this is an agenda that's really hot at the moment, also our understanding of the sort of systemic nature and the business nature of it has also, the economy part of circular economy has also developed and strengthened. Go to the next slide. And on this slide, I would like to hand over to Harry.
Thanks, Richard. So I'm going to talk about the research project, which was the collaboration between Arup and UCL, sponsored by Schneider Electric and supported by AECOM, where we investigated the application of circular economy principles for the MEP systems of UCL's new Marshgate building. So we've taken the findings of that research, and working with CIBSE, we've created this document that you can see on the screen, where we summarize the circular economy approaches that we took to the design of the building services, and also the opportunities, the considerations, and the barriers that surround those. And this presentation is going to give a bit of a taste to what's in the document, but I encourage you to seek it out. It's available for free from the CIBSE website, and there's a link at the end of this presentation. I'll also point out at this stage that the scope of the project allowed for quite a broad but shallow investigation of circular economy for MEP. So it's by no means exhaustive, but what it does show is what happens when you try and put circular economy at the heart of design, and it identifies the opportunities, but also some areas for further investigation. It also includes some quantitative analysis of the design impacts, as we wanted to know not just how circular economy would impact our design, but the effects on whole life cost and carbon emissions for the building. So this is UCL's new Marshgate building in East London. It's a mixed-use university building containing teaching spaces, labs, and offices. The building has a floor area of around 34,000 meters squared, with around a £200 million construction cost. And the building's arranged around this central atrium in green, with 4 cores on the corners, as you can see on the screen. And there are a variety of different space types which depend on the level. So if we have a look at an elevation, if we have a look at the elevation, sorry. Yeah, so there are 2 levels of plant at the top of the building, which are dedicated to plant, so mainly air handling units and cooling plant. And as you go down, there are a number of levels of labs, offices, teaching spaces, all arranged around that central atrium with a basement. And in terms of systems, there's a variety which reflects the mixed use nature of the building. And apologies in advance for my mechanical bias. So cooling is delivered by packaged air-cooled chillers on the roof, and heating is through a connection to the Stratford City heat network. And that delivers water which is hot enough for both heating and domestic hot water. There are some all-air systems which serve labs and technical spaces, combined with some close control units which serve the stores. Yeah, there are also fan core units serving the office areas with mechanical supply and extract ventilation, with the usual ancillary life safety and backup systems that you'd expect. So it's a heavily serviced building, and it contains a big mix of systems. So the opportunity for the research project arose through an aspiration of the UCL team, which was to be really ambitious and to go beyond BREEAM. So we decided to see if we could try and tackle some of the day-to-day and systemic issues that we faced in the MEP world by leveraging some circular economy principles. So we ran this experiment alongside the main project, which at the time was a REBA Stage 3. And the first stage was to establish the main issues faced by the UCL team and try and tailor the more general, generic circular economy principles that are out there to try and address those issues. So we started by holding a number of workshops between ourselves, the wider project team, to identify the most prominent issues which are faced by the operators. And we chose to focus on those that we could extend to the wider industry. So after a number of workshops, the top 5 issues that we set our sights on were the fact that upfront cost is often a much greater driver for design than the cost of a system over its life, and that has knock-on effects to the end of construction and even into operation when time and money for commissioning and training has been squeezed. Next, that the current model for design and construction often fails to consider and include the FM team, which leads to a loss of information, poor transfer of knowledge between designers, contractors, and facilities management, which really contributes to a performance gap between design and installation. Thirdly, there's a need to future-proof our buildings and allow them to easily evolve and change to meet users' needs. Number 4 is that there's a large amount of unrealized secondhand value in MEP equipment. So MEP equipment and components, they're often discarded, either scrapped or sent to landfill at the end of their kind of service lives, even if that equipment still retains value, can still deliver a certain level of performance. And finally, energy use. So energy is often wasted through inefficient system operation, which is contributed to through the lost information between the design and FM teams. So those workshops led to the creation of 5 scenarios, and each scenario was a kind of thought experiment, putting a different aspect of circularity at the heart of design, aimed at tackling those issues that I've just talked about. We took those scenarios and we designed the building 5 times, once for each of them, all the while staying a stage behind the actual design. We then undertook life cycle analysis for cost and carbon, which gave us results for each scenario in isolation. So what were those scenarios? And here they are. So universal, joint venture, passive, recover, and pre-loved. So I'm going to run through what each of them mean and the impact it had on our design, starting with universal. So universal was a response to the need to future-proof buildings and avoid early obsolescence. And the premise is that simple, flexible buildings get better with time, while more complicated, inflexible buildings tend to get worse. And the main point is that buildings tend to be torn down before the end of their expected life, because they can no longer meet the needs of the user, which have changed over time. And to make a building universal, we first need to define the horizon of the potential future uses, designing for the most onerous case to avoid that early obsolescence. We can then test the building with a few different floor plate arrangements to make sure that those different future uses can actually be delivered. And the relevance to circular economy is that these adaptable buildings, they can retain their value for longer, and the materials within the building stay at their highest value for as long as possible. So really this scenario comes into play during the operational period. The building can be straightforwardly and affordably reconfigured in the event of a change of use. In the case of the UCL Marshgate building, we found that the most onerous condition was for 40% of the floor area to be dedicated to high spec labs. For the original brief, the original building, we already had 25% for labs, so there wasn't a huge change in design to allow for that potential 40. And the greatest changes were actually seen by the electrical systems, and that included increasing the electrical capacity by around 15% to meet that future demand. Changes to the design of distribution, which included the increased use of bus bars in the fit out and the shell and core areas, which allowed a bit more flexibility, a bit more of a modular approach. And and that there was a much greater demand put on the generator system, as all the lab DBs required some backup power. We also made considerations of the plant room sizes. Are they sufficient enough to accommodate a change of use? Are the floor to ceiling heights enough to allow for possible increases in the depths of distribution? And is our plant accessible enough for straightforward replacement or upgrade without being disruptive to operation? So our next scenario is joint venture. So traditionally, the way projects are run, there are a number of different parties, all with their own aims and incentives. So as a result of that, the drivers for those parties and those stakeholders tend to be misaligned. So clients want one thing, contractors want another, consultants want another, FM teams want another. And a joint venture scenario aims to align the incentives of all of the stakeholders throughout that supply chain by putting them under the same financial umbrella, where the ultimate aim, the combined aim of all of those, that whole team, is to deliver system performance. And that ensures everyone's aligned. It helps close the performance gap and get the most value out of the equipment and the component materials. And that's the relevance of circular economy here. It's maximizing the value that we can extract from those materials. It also helps to ensure that systems are set up, commissioned properly, rather than the traditional model of procurement where budgets are squeezed towards the latter stages of projects, which can lead to a risk of loss of quality as completion of the project is really the main driver rather than the performance of the system. And that can be compounded by the loss of information between the parties. So this has an effect on the entire life cycle. So from procurement and construction through operation right through to end of life. And it can be difficult to make this kind of thing work because of the unusual contractual arrangements and the public perception of high profile PFI schemes which haven't been so successful. But it is on that point worth noting that there are successful examples of design, build, operate, maintain contracts which are more common in other parts of the world. There are also some really good examples of suppliers who provide products as services. For example, Philips Lighting or Signify, providing lighting as a pay-per-lux service based on leasing agreements, where there are penalties for not providing performance on certain KPIs written into the contract. And for the Marshgate building, when we applied this scenario, we found that although we'd expect to go for more simple systems that the team were comfortable with operationally, especially if we were to suffer financially if they didn't perform, we found that after engaging Schneider, that they were more, Schneider, our manufacturer partner, they were more than comfortable to go for more complex systems so that we could get the best performance, as they'd be more closely engaged with operation and maintenance. And as designers, we wanted to make sure that we could closely monitor system performance. So we designed using more sensors, introduced additional comms networks for off-site monitoring. And that allowed us, well, would allow us to take a more data-driven approach to plant sizing and using modular systems that we could adapt and change if the demands required. We also gave consideration to the use of more efficient but more expensive water-cooled chillers with cooling towers in the addition of a second higher temperature chilled water system. Before I move on, key consideration to make outside of design is the way that contracts are set up and the way that risk is apportioned. That's particularly important, but it could be used to make the kind of arrangement more attractive to building owners who can benefit from sharing the risk, but also the improved performance that comes from taking this kind of approach. Okay, scenario number 3 is passive. And I think this is one that we're all going to be familiar with. The concept of passive buildings has been around for a while. So this approach minimizes the use of active systems, replacing them with passive processes such as natural ventilation and daylighting. And it's circular in a sense, Richard touched upon earlier, that resource consumption and waste is designed out from the beginning. And passive is a design focus, but there are obvious knock-on impacts to operation. And really what's key to this scenario is that it relies on clients and developers being flexible with design criteria. So early engagement on that subject is really important. For the Marshgate building, we had to start by questioning the brief. So do we need these tight design conditions? Can we relax them? And are the systems going to still be reliable enough for our client? And by asking those questions, we were able to remove one floor of plant space, which was previously dedicated to air handling units, providing mechanical ventilation to office spaces and some of the less critical labs. And of course, a significant amount of mechanical cooling, and that reduced the electrical capacity, I think to around 55% of the baseline, and then more knock-on effects of reducing the amount of mechanical and electrical distribution within the building. We also had to look at the floor plate arrangements to facilitate that effective natural ventilation. And that last one falls outside the scope of circular economy for MEP. Really, it's an architectural impact, but it goes to show how closely linked these things are and how that cross-discipline collaboration is really key to implementing this kind of thinking. So our next scenario is recover. And I think, again, this is something that we'll all be familiar with. In this scenario, we aim to minimize the reliance of the building on external resource flows, so focusing mainly on water and energy. And of course, the starting point is to reduce demand as much as possible. So you can kind of look at this scenario as passive plus. And it's really important also to consider the scale of the project and match it to the scale of the resources. So for example, it may be more efficient to use larger off-site renewable power or heat as opposed to smaller, less efficient installations on sites. That's something that will vary from project to project. And here we really wanted to test the principle. So again, recovery is a fairly design-focused response with those knock-on effects through construction and operation. And again, it's predicated on being able to achieve agreement on those suitable comfort criteria and having freedom to change the architecture to make it work as with passive. So for the Marshgate building, we took passive as our starting point, and any equipment we retained, we upgraded to high spec to make the most out of high efficiencies and reclaim as much energy on site as possible. So we weren't consuming those external resources. We also swapped the connection for to the district heating for ground source heat pumps and air source heat pumps. Again, just to recover as much wasted heat on site as we could. And we also gave a lot of consideration to improving the performance of the building's envelope to make sure that we saved as much operational energy as possible. And again, that highlights how this not only impacts the MEP, the building services, but it's really a cross-discipline design approach. Okay, the fifth and final scenario is pre-loved. And I think this is probably what most people jump to when they hear circular economy. So here we think about how we can incorporate second-hand equipment into new buildings and make sure that the materials and the components are reusable at the end of their life in the building by designing for disassembly. And over the life of the building, it looks something like this. So design is affected by allowances in specifications and early stage, but procurement really is the stage that's most heavily influenced. At the end of life, end of the equipment's life, that equipment re-enters the market for reuse, refurbishment, to minimize the amount of material that's sent for scrap or to landfill, which is largely the current model. And to do this, we had to make a big assumption, which was that there's a second-hand market which allows us to do so. For the Marshgate, this building, this had a little impact on the actual design, the main difference being that we assumed that the majority, except for the life safety and the critical systems, were made up of those second-hand components. And there's not really currently, at least, a developed market for second-hand MEP equipment on any kind of commercial scale. This is a bit more of a theoretical exercise. So we found that the key thing for the scenario to be effective is data. So data which provides visibility of performance and reassurance that that second-hand equipment is reliable and it is working as well as if it was new. So to give that visibility of data, we designed using lots of sensors, which is definitely a recurring theme throughout throughout these scenarios. And in this case, the purpose of that data was to keep track of system condition, enable proactive maintenance, but it has the added benefit of giving visibility to performance to allow continuous improvement and close that performance gap. So now to have a look at the results. So we measured the success of each of our scenarios in terms of cost and carbon using life cycle analysis. We couldn't just consider the cost of the MEP systems. As I've touched on, the design implications for each scenario reached across the whole building. For example, improving envelope performance in the case of the recover scenario. But as you can see, there were cost savings made in all cases, and interestingly, savings were made in different places, although it's a little bit difficult to see from this graph. The CapEx does change. I mean, it demonstrates that the value of taking a TOTEX approach to costing rather than separating CapEx and OpEx, which is the traditional way. I should point out again that we use the appropriate level of analysis for the scope of the project. So the results indicate that the range and the scale of the consequences over the building's life, and they're useful for a comparison. But the headline is that none of the scenarios resulted in an increased cost, and in fact, there's a small reduction across the board. And when we look at life cycle carbon, we didn't have time or scope in the project to run an energy model for each of these scenarios, each of our designs. So we focused on the recurring embodied carbon for the services. And again, the appropriate level of analysis, the scope of the project. So the results are useful for the range and as a comparison. It's also worth noting that in this case, a benchmark value for this type of building in London has been used against which to measure. As for the cost, we measured against Universal, as it was the closest scenario we had to the actual brief. So in terms of carbon, there were significant reductions for all of the scenarios, particularly for pre-loved and passive. And that was because of the embodied energy of copper and steel that really were the driving factors. So by using materials already in circulation or by designing them out, the carbon associated with those systems can be significantly reduced, even if they're going to be replaced more frequently. Because it's secondhand and they're in less good condition. So our takeaways. There are 5 scenarios, five ways of approaching circular economy for MEP that we can systematically use in our projects to make them more circular, address the environmental and user level challenges. And in this case, they were all proven to be effective in reducing the life cycle carbon of the building and having a small positive impact on cost. And these briefs, they create a space for design. Each project is going to lend itself to a different approach or a different combination of approaches. Of course, we only looked at the scenarios in isolation. Thirdly, it's really important to remember that circular economy impacts briefs. So we need to try and embed this kind of thinking as early as possible in projects to really get the most out of it. As I've said a few times, taking a circular economy approach to the MEP systems on this project had an impact on the total architecture of the building, so not just the MEP systems. There's a real requirement for close cross-discipline, cross-sector collaboration, and consideration needs to be given to how the building changes over time, not just the systems within the building. And finally, circular economy is more than just making components recyclable or reusable, and we've demonstrated that in this case we can significantly reduce the life cycle carbon without it costing any more, and in fact it being less expensive. And that just shows that we can use circular economy to tackle these environmental challenges and the challenges faced by end users by establishing a sustainable business case around it. And now for the final bit. Why is this stuff relevant to city members, and what are the next steps? So we're all familiar with the environmental drivers, which are the fundamental reasons for doing all these things, but there are also significant financial and performance benefits of applying circular economy through contractual arrangements, such as products or services, and joint ventures, discounted secondhand equipment, and opportunities around selling and repurposing secondhand equipment. on top of that, policy is starting to creep into the UK construction industry, with London leading the way. So as part of the new London plan, all new referable developments to the GLA will be required to submit a circular economy statement. They'll also be required to submit a whole life carbon assessment and demonstrate how the reductions can be made. And that whole life carbon assessment includes MEP. DEFRA's waste and resources strategy for England, it places a lot of emphasis on shifting towards a circular economy, and the UK GBC have recently published some key policy asks around the subject. And finally, clients are starting to recognise the need. For example, Crown Estate, who've included circular economy in their sustainability strategy, are including it now in project briefs. And that makes sense, because as shown by this research, there can be considerable opportunities to improve the quality of their buildings using circular economy as a tool. And finally, in terms of next steps, pretty short, it's time to start engaging clients and suppliers, and trying to explore how we can start to implement this kind of thinking in our projects. Thanks. I think we've got some time for some questions now.
Thank you very much, Harry and Richard. Yes, we do have some questions. I'm just going to go through them. The first one, did you consider soft landings as a means to ensure fit for purpose, alternative solutions, monitoring progress, improved handover and sustainable operation?
So I'd say yes, definitely. But again, it's something that needs to be kind of embedded in the project as early as possible, rather than something that gets kind of tacked on towards the end. So if it's if the project and the building is set up with the appropriate offsite monitoring and time for training and stuff like that, soft landings are definitely a really effective way of ensuring everything's commissioned properly and all the systems are delivering the performance they should, and that the FM teams are trained properly with appropriate building user guides and things like that. So yes, I think definitely soft landings are something that should be considered in closing the performance gap.
Yeah, I think all I'll add to that is well, two quick things. The first is that I think I sort of circular economy doesn't by no means it doesn't replace much of the great work that's already been done, and sort of it might not be sort of labeled as such, but if you know, soft landings in its principles around sort of continuous commissioning and trying to join up incentives and close gaps really does a lot of the work that circular economy is also trying to do. So I think it's definitely possible for us to adopt or understand the distinctions between sort of where circular economy introduces new concepts. And again, I think the business element and the procurement element of circular economy is quite new, and where it actually sort of supports or helps reframe some of the things that we were doing already, like soft landings and more traditional sustainability approaches.
Okay, thank you very much. Second question. Many economists argue that planned obsolescence is crucial to economic growth. How do you reconcile this with circular economy?
That's a good business model question. And it's a really interesting one. So I guess the first thing I should say is that I'm not an economist, but what I think is really important is that if the business models of the manufacturers and the supply chain remain in the mode of the linear economy, where you manufacture and you sell, and you don't really have a relationship beyond that moment of sale for the equipment, then you need throughput. You need to create obsolescence so that equipment remains replaced, so you can continue to manufacture and sell. And that's the logic that says that waste is designed into our current system, because you have to have designed in obsolescence to keep the economy running. What circular economy aims to do in the sort of the most macro sense, and this is getting fairly conceptual, I appreciate, but it aims to get the supply chain to retool their business models such that they can grow and thrive and survive and thrive without necessarily having that conveyor belt of selling more and more stuff. So if you're providing a service, and I think this comes under our models and sort of in joint venture, especially if you sell a service of heating and cooling rather than selling a product of a chiller, then you can have a cash flow associated with a piece of equipment that might last 40 years, and you still have a business because you're still earning cash flow from that piece that you've made. And at the end of the 40 years, you might be able to update the out-of-date components, but keep the chassis, the casing, the elements of the equipment that might not be so critical to the performance of it, but where lots of the embodied carbon sits, because it sits in the metals and the casing and the chassis and things, and actually resupply that as a new piece of equipment to last another 40 years. So like one casing or one chassis might be able to provide an economic, a cash flow to your business for 80 years, which at present it can't at all, because if you sell it, you get the cash flow, you move on, and it's sort of a much more instantaneous thing. So I think, if we're successful in getting the supply chain and getting plans and achieving the shift to circular models as opposed to linear ones, then we can very much have growth and business success without obsolescence and replacement.
Any of the other panelists?
I would also, just to add to that, say it is something that we see in other industries. So for example, in the automotive industry, engine refurbishment schemes are sort of reasonably common, and it provides an additional revenue stream for a business and skilled labor associated with it, and sort of financial growth in a way that's decoupled from resource use.
Okay, thanks, Joe. Okay, I'll go into the next question, which is what are the challenges and opportunities to introducing circular economy into large buildings such as airports?
I can say a bit, and then maybe Harry might say a bit as well.
Yeah, go ahead.
The challenges and opportunities. Well, I think the opportunities are clear, and I mean I'll have a think about whether it's different for a large or a small building. I don't know if the scale makes a difference. I think the use of the building certainly does make a difference. So something like an airport is designed to only be an airport. And if you think about our universal building scenario, that was talking about like what are the potential future uses of this building for the stakeholder. Now, not many airports are designing their buildings thinking that they might be something else. I think most of them are designed principally to be shopping malls now more than anything else. But the idea that an airport, should something happen catastrophic to the aviation industry, and we're seeing the vulnerability of that industry at the minute. Those assets, what else could they be used for? So I think the opportunity is to partially future-proof your asset against shocks like global pandemics or stresses like climate change. I think the opportunity is also, as our study has shown, around embodied carbon and performance, closing the performance gap. I think the challenge is around and this is where maybe the scale comes in. We're doing something new here, and of course, newness and innovation and novelty brings risk, and there's an appropriate scale at which that risk can be taken on a project. So it's quite difficult to introduce a sort of a new procurement model or business model on an enormous project where millions are potentially at stake if something goes wrong. So we need to be able to, coming back to the urgency point, we need to be able to change quickly, but we also don't want to bring undue risk onto our project. So we need to find a way of prototyping and piloting at appropriate scales in a sufficiently agile and quick way that we learn the lessons and can apply it to the large projects soon without creating undue risk.
Yeah, I think maybe if I'll speak maybe slightly more specifically to MEP, I think one of the it's maybe more of a logistical challenge. So looking at more kind of the day-to-day challenges and actually kind of implementing some kind of some kind of reuse or repurposing of equipment is things like storage on site. There's not a lot of space or time when things get stripped out, and then identifying an immediate need or an immediate place that equipment can be used. So on a kind of day-to-day scale, there's the logistical setup at the moment is not kind of not currently in place for an effective circular economy. In terms of an opportunity, there's, if you think about developers or clients with large portfolios of buildings and constant buildings going up, buildings coming down, with MEP assets going in and out, maybe there's some opportunities around those for reuse and looking to internally provide those logistics. Of course, at the moment, it's starting to come in, but policy as well isn't currently driving this kind of thing. But as it does, I'm sure that that's going to rather than be a barrier, be a kind of a driver for this for circular economy.
Okay, thank you, Harry. I don't know, Joe, if you have something to add, or should I go to the next question?
I guess just to add for projects like that, to go back to what Richard was saying about looking for ways we can explore these principles without adding undue risk. I suppose maybe it's useful, as you mentioned, to look at the fact that large portions of airports are designed to be almost shopping malls, and that you could look at, potentially forecast for turnover in tenants to all these retail spaces that are let out, and look for opportunities for maybe standardization or flexibility there to reduce the amount of waste that's produced when those spaces are sort of where tenants turn over and spaces are refit and stripped out.
Well, thank you very much. The next question, would an example of the joint venture scenario be an integrated project delivery contract, which is most popular in the US?
The short answer is yes. The slightly longer answer, caveated a little bit, is that we've heard a bit about IPD, integrated project delivery, and I think some ideas that are central to that around shared project bank accounts are really, really important and really, really successful at aligning the incentives, and that's what the joint venture scenario is all about. It's trying to make sure that risks are shared, pains are shared, but gains are shared, and if everybody pulls together and performs well, then everyone does well, and the client ultimately gets a better performing asset as a result. So yes, I think that is a good example, and we're even interested to sort of learn more and find out more on this side of the Atlantic about how IPD ideas and approaches could be brought into our projects.
Okay, thank you. Should I go to the next question, which is about ownership? So most commercial buildings are not built for the owner. Would you agree that a move to owner occupiers would improve the take-up of whole life considerations? And then the second part of the question or statement is this would require a change in practice, lease agreements, and perhaps tax laws.
Yeah, so this is, that's a really great question, because it's really getting at sort of the business elements and the non-design elements that really dictate what the room for maneuver that designers have. In the commercial space, I'm not sure we can really say we can really advocate a shift one way or the other. That's kind of up for occupiers and the sort of asset management industry to decide for themselves what works. We know that there have been some recent changes to accountancy rules around leasing that has led to some organizations changing whether they own or lease spaces, which I think is probably working in our favor. I would highlight, though, to be a bit more specific, the shift that we've seen in the London market anyway around build to rent and residential. So previously, the market was almost entirely build to sell, and that led to sort of short-term thinking. Build to rent, however, does mean that the building has to design to perform, and it needs to perform well for for the occupants over time to remain its sort of keep its attractiveness. And there are some of our models that we sort of see, especially around again, a little bit joint venture, maybe a little bit around pre-loved, sort of come into their own because you want to be able to differentiate your asset against lots of others in like quite competitive space, as well as thinking for the long-term value of that asset rather than just sort of its immediate sale value.
Thank you. Harry or Joe, do you have anything to add?
No, not really. I think Richard said it all there about yeah, the elimination of short-term thinking and extending that over the life of the building is important.
Okay, thank you. So the next question is regarding the pre-loved scenario. How would liability be dealt with? Who takes it on? The second-hand reseller or the client or other? Again, in ownership, I guess it's in the same kind of subject.
So what we assumed in the pre-loved scenario was that, well, we assumed it and then we discussed the assumption with Schneider. And in our discussion with Schneider, they shared with us that they already have this as part of their business. So it sort of ceased to be an assumption and became something that was actually quite tangible. They have a part of their business that takes back some equipment that they previously made, and they remanufacture it and they resell it with a full warranty, full liability covered, as if it was a new piece of equipment. And they might sell it at a small discount because it's remanufactured, but ultimately it has a very similar value to a new piece of equipment because it actually performs just as well as a new piece of equipment. So in our pre-loved scenario, we assumed that the supply chain would be re-warrantying and recertifying the equipment, and therefore the upfront cost reduction that we were assuming was actually quite modest, of the order of about 10%. So your second-hand equipment isn't that much cheaper than your brand new equipment, but it performs the same, so you still take that saving. And it has a significantly lower embodied carbon because, as I said, sort of the carbon intensive elements are reused and going into their second life.
Okay, thank you. Any other points?
I think it's something also that needs to be explored and tested as more manufacturers look to do that kind of thing. Yeah, and warranties are quite key to making it work, to making it attractive to building owners, so that they don't have to take that risk. But I'm sure it will change on depending on the scale of the systems and of the components and the specific part of the market where it sits.
Thank you. I have another question here. I don't know if you will know the answer, but I think it might be, well, you will definitely have an opinion about it. It says, are companies really adopting circular economy principles for the London plan? Is this likely to be a greenwash statement? How will it be tracked to demonstrate implementation?
I think you're likely right. We can offer an opinion. How it's going to be tracked is really up to the GLA. For my part, I haven't yet seen guidance as to what that will look like. I've seen guidance as to what the circular economy statement would look like. I haven't seen guidance as to how it's going to be followed up. I think with anything new, there's of course going to be an element of sort of bedding in and trialing, and that's fine. That's part of the process. You know, I think it's really positive that it's been asked for, and I think you know, we gave some insight or shared some perspectives into its development, and so we're quite happy that it's here, and think it will provoke some interesting questions with clients. I mean, I'll just finish by saying it'll really be up to or come down to design teams and their clients responding to it in a substantive way. You know, if people really buy into it, it'll be very useful. If people don't really engage with it and see it as something that's not of value to their process, then it will not have the impact that it could have.
Yes, absolutely. Harry or Joe, if you have any closing statements, we reached 12 o'clock, so I will need to close the webinar.
No, nothing from me there. I think Richard said it really well.
Yeah, I
Good.
think Richard summed that up pretty well. It's yeah, it's all about buy-in and making sure there's the transfer of information of the design intent through to the client and the FM teams who can apply it in operation.
I guess there are obvious financial benefits in following the circular economy, and perhaps that's one way that the London Plan can implement and track the implementation of circular economy principles. But yes, that's a subject for another webinar. Okay,
Absolutely.
thank you very much, guys. Thank you for the presentations and for answering questions. I thank you everybody for tuning in and for your questions. And I will say goodbye and thank you again very much. Bye bye.
Yeah, thank you.
Thanks everyone.
Thanks.
Bye.